Okay, lesson 15, linear equations and two variables. Emily tells you that she scored 32 points in a basketball game with only 2 and 3 point baskets, no free throws. How many of each type of basket did she score? Use the table below to organize your work. Well, number of 2-pointers, well, she can score 16 2-pointers because 16 times 2 is 32 and get 0. She can score 13 times 2 is 26 and 2 free throws. She can score 10 and 4. She can score 7 and 6. She can score 4 and 8. And she can score 1. And she can score 10. And I'm going to move this because I have one thing on here that I don't want. There we go. Now, okay. So, it says let X be the number of 2-pointers and Y be the number of 3-pointers. Okay. Write an equation to represent the situation. Well, to write that, the 2-pointers, 2 times the number of 2-pointers, plus 3 times the number of 3-pointers would give us the total points that Emily scored. Okay. So now it says an equation in the form of AX plus BY equals C is called a linear equation in two variables. It is also referred to an equation in standard form. Okay. We have been working with a slope-intercept form, which is y equals mx plus b. The equation 2x plus 3y equals 32 is an example of a linear equation in two variables. Is the equation you wrote in the opening exercise in standard form? The answer is yes. In the equation ax plus by equals c, the symbols a, b, and c are constants. What then are x and y? X and y are unknown numbers. Called variables. Okay? All right, next. So for example, negative 50x plus y equals 15 is a linear equation in x and y. As you can easily see, not just any pair of numbers, x and y, will make the equation true. Consider x equals 1 and y equals 2. Does it make the equation true? Well, if we substitute that in, and solve, negative 48 does not equal 15. So no, because negative 48, again, does not equal 15. So what pairs of numbers did you find that worked for Emily's basketball scores? Did just any pair of numbers work? And explain. Okay. here, okay, I helped you here, okay? We identified pairs. From the table. And not just any pairs worked. Okay, so for example, okay, 15 2-pointers and 1 3-pointer equals 33. And that one doesn't work. Okay, so now a solution to the linear equation in 2 variables is an ordered pair of numbers, x, y, so that x and y makes the equation a true statement. The pairs of numbers that you wrote in the table for Emily are solutions to the equation 2x plus 3y equals 32, because they are pairs of numbers that make the equation true. How do we find an unlimited number of solutions to a given linear equation? Well, here's what we do. We pick a number for x or y. The second thing we do is substitute and simplify. Okay. 3, we solve the equation. For the remaining unknown. Okay, so for example, if we pick x equals 4 for this linear equation, okay, then we substitute in negative 50 times 4 plus y equals 15. We have negative 200 plus y equals 15. And we add 200 to both sides. We find that y equals 215. So our solution then is 4, 215. So when we put that in here for x equals 4, we have negative 50 times 4 plus y equals 15. We have negative 200 plus y equals 15. And y equals 215. Next, if I want to try, for example, y, and I say y equals negative 10, I would substitute that in and say negative 50x minus 10 equals 15. I would add 10 to both sides. So then I would have negative 50x equals 25. And then I would have divide both sides by negative 50. Therefore, x would equal negative 1/2. half. So then, so here I put in x. Here I'm putting in y. So putting that in, 50x plus negative 10 equals 15. Negative 50, x minus 10 equals 15. Our answer here is negative 1/2. Okay, so in this case, our solution and our point is negative 1/2, comma, negative 10. Okay, so now the next thing that we would want to do is, working with a partner, I'm going to have you find 5 solutions for the linear equation 2x minus y equals 10 and plot the solution as points on a coordinate plane. Okay? So here, I'm simply going to have you use the first, I'm going to use 1 through 5. So if x is 1, and use your workspace down here. So I'm going to move this up just a little bit. Okay? And I'm actually going to use a little bit of workspace in here as well. So if I have 1, okay, so 2 times 1 minus y equals 10. So 2 minus y equals 10. So my workspace is going to be 2 minus y equals 10. So subtract 2 from both sides. So I have negative y equals 8. Divide both sides by negative 1. So y equals negative 8. Okay, so we have negative 8 here. So I have 2. 2 times 2 minus y equals 10. So 4 minus y equals 10. So I have 4 minus y equals 10. Let's do that work. Negative y equals 6. Divide by negative 1. Y equals negative 6. I have 3. 2 times 3 minus y equals 10. 6 minus y equals 10. We'll move this up a little bit so you can continue to see my work, because that's important. So we have 6 minus y equals 10. Subtracting that from both sides. Negative y equals 4. Divide both sides by negative 1. Y equals 4. Or sorry, negative 4. Next is 4. So we have 2 times 4 minus y equals 10. So 8 minus y equals 10. So we have 8 minus y equals 10. Subtract 8 from both sides. So negative y equals 2. Divide both sides by negative 1. Y equals negative 2. And then finally, 5. We have 2 times 5 minus y equals 10. 10 minus y equals 10. So now we have 10 minus y equals 10. Subtracting 10 from both sides. Negative y equals 0. Divide both sides by negative 1. And y equals 0. So now we need to not only write these out, we need to plot the solution on a coordinate plane. Here's our coordinate plane, ladies and gentlemen. We need to mark it x and y axes. We're going to plot these points. So we've got 1 and negative 8. So we have 1 and negative 8 right here. We have 2 and negative 6, 3 and negative 4, 4 and negative 2, and 5 and 0. So now we are going to draw the line, ladies and gentlemen. Make sure you use a straight edge or ruler. Go all the way through the graph, as I just have. And make sure you label your line. Our line is 2x minus y equals 10. And that is the end of our lesson.